Hello, I'm Guruprasad Upadhya. So in this lecture, I'm going to discuss the inverse Laplace transform sum problems of the 18MAT31 module 1. You know some rules of the inverse Laplace transform. Suppose the function of s minus a is given. To find the inverse Laplace transform by the first shifting rule, so it is nothing but e power at into L inverse of function of s. That means s minus a is replaced by s, find its inverse. So that becomes f of t into e power at. Similarly, if it is function of s plus a, e power minus at into L inverse of function of s. S plus a is replaced by s. So this is rule 1. Just remember this rule. Suppose if you don't have any formula or rule to find the L inverse of f of s. If you know the inverse Laplace transform of derivative of f of s, then use this rule. Minus 1 by t L inverse of derivative of this f of s. Just differentiate this f of s with respect to s, then find its inverse Laplace transform, multiply it by minus 1 by t. So that is L inverse of f of s. So this is useful to find the L inverse of log of function of s or cot inverse of function of s and so on. One more rule is, if the function given is f of s into e power minus as from the unit step function Laplace transform, so if it is e power minus as a product with f of s, find the inverse Laplace transform of f of s, then t is replaced by t minus a. See, L inverse of f of s is f of t. If t is replaced by t minus a, it becomes f of t minus a into unit step function u t minus a. So remember these three formulas. So I am going to discuss some questions to how to find inverse Laplace transform using partial fraction method and using first rule, second rule and third rule. Okay. Now the first question, find the inverse Laplace transform of the function 4s plus 5 by s minus 1 whole square into s plus 2. Now assume that 4s plus 5 by s minus 1 whole square into s plus 2 is equal to a by s minus 1 whole square plus b by s minus 1 plus c by s plus 2. Now to find a, b, c. Now see this, denominator of a is s minus 1 whole square. So close this in left hand side, close this, and denominator of a becomes 0 when s is 1. Put s equal to 1 in the remaining terms. That means 4 into 1 plus 5 by 1 plus 2. So it becomes, when s equal to 1, so it is 9 by 1 plus 2 is 3. 9 by 3 is 3. And similarly, to find the value of c, in the left hand side close s plus 2, write the remaining term, that is 4s plus 5 by s minus 1 whole square, and denominator of c becomes 0 when s is minus 2. So put s equal to minus 2. So you can use calculator also. How to use calculator for this? First you make minus 2 is the answer, minus 2 equal to, then type like this, 4 answer plus 5 by answer minus 1 whole square. So you get minus 1 by 3. After finding a and c value, see here, if I multiply throughout by s minus 1 whole square into s plus 2, the first term becomes a into s plus 2, second term is plus b into s minus 1 into s plus 2 plus c into s minus 1 whole square, and left hand side is 4s plus 5. Now when you compare the coefficient of s square both sides, left hand side there is no s square in the numerator, therefore 0, coefficient of s square is 0. Right hand side b plus c, so b plus c is 0, therefore b is minus c, minus of minus 1 by 3. So b equal to minus c, and hence b value is 1 by 3. Once again I repeat this. See, if you multiply throughout by s minus 1 whole square into s plus 2, here a into s plus 2, that means degree 1 term, b into s minus 1 into s plus 2. So s square into b plus something. Here c into s minus 1 whole square, s plus 2 cancel, c into s minus 1 whole square. So s square term is c. The coefficient of s square in the left hand side becomes b plus c. Right hand side in the numerator there is no s square term, because when you multiply throughout by s minus 1 whole square into s plus 2, this cancels, only 4s plus 5 remains. Therefore b plus c is 0 and hence b is minus c. After finding a value, b value and c value, inverse Laplace transform of this is nothing but inverse Laplace transform of 3 by s minus 1 whole square plus 1 by 3 by s minus 1 minus 1 by 3 by s plus 2. And we know the formula. Suppose this is by applying the first rule in the inverse Laplace transform. Assume that this is function of s minus 1. So L inverse of function of s minus a is L inverse of function of s into e power at, e power 1t. So e power 1t into L inverse of 1 by s square. 1 by s square inverse Laplace transform is t. Therefore, it is t e power t into a. A is 3. Therefore, required answer is 3t e power t, that is L inverse of 3 by s minus 1 whole square, plus b is 1 by 3 and L inverse of 1 by s minus 1. So, that is e power at, e power 1t, plus c is minus 1 by 3. L inverse of 1 by s plus a is e power minus at. Therefore, e power minus 2t. So, this is how we can find the L inverse of 4s plus 5 by s minus 1 whole square into s plus 2. So, this is partial fraction method. So, it is very simple logic. Please go through this once again and try some other problems also. One more example. Here, in the denominator, we have s minus 1 into s square plus 2s plus 5. Now, we are not able to factorize this because the roots of, suppose s square plus 2s plus 5 equal to 0, then roots are imaginary roots or complex roots. Therefore, how to make it as perfect square method? So, half of this coefficient of s is 1. This denominator of this s square plus 2s plus 5 becomes s plus 1 whole square plus 4, because s plus 1 whole square is s square plus 2s plus 1 plus 4. So 5 is nothing but 1 plus 4. So 1 is taken with s square plus 2s. Then how to assume the partial fraction for this? So first term is linear, s minus 1, therefore it is a by s minus 1. So this is quadratic irreducible factor, therefore assume that numerator is of degree 1, that is bs plus c. Now find a, b and c. To find a, it's very simple. Denominator of a, close this, put s equal to 1. 5 plus 3 is 8. 1 plus 2 plus 5 is 8. 8 by 8 is 1. Therefore, a is 1, direct 1. But to find bs plus c, multiply throughout by s minus 1 into s square plus 2s plus 5. Here a into s square plus 2s plus 5 plus bs plus c into s minus 1. Now, the coefficient of s square is, here a is 1, coefficient of s square is 1 plus b into s, b square. 1 plus b equal to, left hand side there is no s square, therefore it is 0. And hence b is minus a means 1, minus 1. And then put s equal to 0 both sides. Left hand side here 0. When s equal to 0, these two become 0. Here 5. When s equal to 0, this becomes 0. C into minus 1. So minus c. 5 minus c is 3. And c is 5 minus 3. And hence c becomes 2. Now after finding a value, b value and c value, now to find the inverse Laplace transform, write this as 1 by s minus 1 plus, here a is 1 by s minus 1, and this denominator s square plus 2s plus 5 can be written as s plus 1 whole square plus 2 square. See this, take the half of the coefficient of s that means 2 by 2 is 1. So s plus 1 whole square. So s square plus 2s plus 1. The remaining term is 4. Here 5 is there. So 1 plus 4 is 5. Now numerator a, b, s. Now s is written as s plus 1 minus 1 and c is 2. So s plus 1 minus 1 with the minus sign outside because b is minus 1. So minus s. So minus s plus 1 minus 1, minus of minus plus 1, here 2. See, when we simplify this, it becomes minus s. So b is minus 1 minus s plus c, that is 2. So minus 1 plus 3 is 2. See, why we numerator is expressed like this? Because to make this as function of s plus a. Therefore, its inverse becomes function of s into e power minus at, e power minus 1t. And hence, the inverse Laplace transform of the given function is 1 by s minus a means e power at, its inverse is e power at, e power 1t. And s is s plus 1, therefore e power minus t into, replace s plus 1 by s. So s plus 1 is s means s by s square plus 2 square with minus sign. So minus s by s square plus 2 square is nothing but its inverse is cos 2t. And one more term is 3 by s square plus 2 square, 3 into 1 by s square plus 2 square, 1 by 2 sin 2t. So 3 into 1 by 2 means 3 by 2 sin 2t. So this is the answer, final answer for L inverse of this function. Once again I repeat, when you replace s plus 1 by s, this becomes minus s by s square plus 2 square plus 3 into 1 by s square plus 2 square. So its inverse is minus cos 2t plus 3 by 2 sin 2t multiplied by e power minus t. That is the first rule. Using the first rule, we got the answer like this. Okay. Next question is, here L inverse of s minus 1 whole square by s minus 3 whole power 6. Now denominator only one term, s minus 3 whole power 6. Therefore, numerator s is replaced by s minus 3 plus 3. This s is nothing but s minus 3 plus 3. Then this minus 1. Just write s is s minus 3 plus 3. Now this is function of s minus 3. See this, s minus 3 plus 3 minus 1 is plus 2 whole square by s minus 3 whole power 6. Now s minus 3 is replaced by s multiplied by e power 8, e power 3t. Therefore, its inverse is e power 3t into L inverse of this s minus 3 is s plus 2 whole square divided by s minus 3 is s power 6. Now just expand the numerator, s square plus 4s plus 4 divided by s power 6 and then separate it. So s square plus 4s plus 4 by s power 6 means s square by s power 6 is 1 by s power 4 plus 4 by s power 5 plus 4 by s power 6. And we know that L inverse of 1 by s power n is t power n minus 1 by n minus 1 factorial. Therefore, inverse of 1 by s power 4 is t cube by 3 factorial plus 4 into t power 4 by 4 factorial plus 4 into t power 5 by 5 factorial. And hence, the answer is e power 3t into t power 3 by 3 factorial is 6, 4 into t power 4 by 4 factorial is 24, 4 by 24 is 1 by 6 and 4 into t power 5 by 5 factorial is 120, 4 by 120 is 1 by 30. So this is L inverse of Laplace transform, inverse Laplace transform of s minus 1 whole square by s minus 3 whole power 6. Same type, one more question. S square minus 2s plus 2 by s minus 2 whole power 6. So in the denominator s minus 2 whole power 6. Therefore, in the numerator s is replaced by s minus 2 plus 2. That means s only. But first write it as s minus 2 plus 2. S minus 2 plus 2 is nothing but s. Therefore, s square s minus 2 plus 2 whole square minus 2 times of s minus 2 plus 2 times of s plus 2. This is first step. Now this becomes function of s minus 2. Therefore, e power 2t by first rule, e power 2t into L inverse of function of s. E power 2t into L inverse of function of s. That means s minus 2 is replaced by s. So, s plus 2 whole square minus 2 times of s plus 2 plus 2 by s power 6. Now, simplify this. S square plus 4s plus 4 minus 2s minus 4 plus 2. So, 4 minus 4 cancels. 4s minus 2s is 2s. This 2 remains. Therefore, it becomes s square plus 2s plus s by s power 6. Now, separate this. 1 by s power 4 plus 2 by s power 5 plus 2 by s power 6. And 1 by s power n L inverse is t power n minus 1 by n minus 1 factorial, and hence it is e power 2t t power 3 by 3 factorial plus 2 into t power 4 by 4 factorial plus 2 into t power 5 by 5 factorial. Now 3 factorial is 6, 4 factorial is 24, cancel 2, so it becomes 12, 120 cancel 2, so it becomes 60. Therefore, answer is e power 2t into t power 3 by 6 plus t power 4 by 12 plus t power 5 by 60. So, that is inverse Laplace transform of s square minus 2s plus 2 by s minus 2 whole power 6. One more example. So, here we do not have any formula of that cot inverse of s minus a. Then use the second rule. So, we know the derivative of tan inverse x or cot inverse x. So, derivative of cot inverse x is minus 1 by 1 plus x square. Here s by a minus 1 by 1 plus s by a whole square into derivative of s by a is 1 by a. And we know the inverse Laplace transform of that function. Therefore, use the second formula, that is minus 1 by t L inverse of derivative of f of s. Here f of s is cot inverse of s by a minus 1 by t L inverse derivative of cot inverse of s by a. So, it is minus 1 by 1 plus x square, that means s by a whole square into derivative of s by a is 1 by a. By taking in the denominator, you take the common denominator, a square plus s square by a square. So, in the denominator is a square goes to the numerator, cancel 1a. So, it is minus a by s square plus a square, take minus outside. So, minus minus plus 1 by t into L inverse of a by s square plus a square. We know this. Laplace transform of sin at is a by s square plus a square. Inverse Laplace transform of a by s square plus a square is sin at. So, 1 by t into sin at is sin at by t. So, this is the answer for inverse Laplace transform of cot inverse s by a. Followed? Okay. Next question. Now, next question. L inverse of e power minus as by s plus p whole square. Here we have e power minus as. So, use the third rule. L inverse of f of s into e power minus as is, just find L inverse of f of s, that is f of t, and then t is replaced by t minus a multiplied by unit step function u t minus a. So, this is second shifting rule, inverse Laplace transform. Okay. Now, here f of s is 1 by s plus b whole square. S is s plus b. Therefore, e power inverse is e power minus bt into 1 by s square. Replace s plus b by s. 1 by s square inverse is t. T e power minus bt. That is f of t. Then t is replaced by t minus a and multiplied by u t minus a. Now, L inverse of f of s, that is 1 by s plus b whole square, then t is replaced by t minus a into u t minus a. So, 1 by s plus b whole square inverse Laplace transform is t into e power minus bt. Now, t is replaced by t minus a means t minus a into e power minus b into t minus a into u t minus a. So, this is required answer. Okay. So, using third rule. Followed now. So, we discussed some problems of the inverse Laplace transform. So, in the next video, in the next lecture, 8th I am discussing more problems on the convolution theorem and how to solve the differential equations using Laplace transform. Thank you for watching.